I would like to know a little bit of what's your framework for determining if a particular computer vision application it's possible. I mean, I know that there's always a bit of experimentation, but in general, what would you say that they are the most common steps that you normally take towards being able to assess the viability of a particular project?
For it to be accessible to computer vision, first of all, you need images or some other spatial type of information. It could be video, it could be 3D data, it could be point clouds. There needs to be spatial information. It could be spatial plus something else, but that spatial information is key. So you need to have those images available. The number of them that you need is very much going to depend on the project, but larger quantity is certainly better. Typically, you're trying to predict something from these, so detect an object, predict whether a mutation is present or not, predict how much this power plant is producing, different labels like that. So you need to have those labels available or at least attainable. So can a human annotator go in and annotate those for you? Or do you need ground truth data from these power plants, their self-reported data saying what they're doing at this particular time? Those labels need to be attainable for you to be able to learn anything. So you need to consider the size of the image data set, how many labels you might be able to collect. You need to consider the quality of these images, if they're completely noisy, filled with artifacts, if the labels you have are all over the place, done by different annotators and don't make any sense. You've got a quality problem that might pop up later, so that's something to catch in the beginning. And I guess another thing is, can humans see the signal that you're looking at? It's not a deal breaker, certainly, because in the breast cancer example, these are things that pathologists cannot see from that image. But it's going to be easier if a human can see the signal that you're trying to predict. If they can't, it's probably harder, but those are kind of my favorite applications to tackle anyway. It just means there's going to be a heavier research component. So those kind of revolve around the data. Um, Beyond that, you need a clear problem definition. So, what is the task that you're trying to accomplish? Are you trying to automate something? What business problem does it solve? Like, if it's just for fun, it's probably not going to make you any money. And so, if you're a commercial entity, that might not be the smartest path, but it needs to solve a business problem if this is a business application. You'll need infrastructure for the data and for the compute. You need to be able to build that. You need to have resources in order to build that. And one piece that's sometimes missing is domain expertise. So you might already have those domain experts who know what those images are, know what's in them, know what the complications will be. But if you don't, it's going to be more challenging. You need somebody who understands what's going on in order to help guide what should be looked for, what complications are likely to come up. Um, that domain expertise is essential.